It's just wonderful to see engineers congregating together.
I'm really excited to be here at the RISC-V conference.
It's fantastic just to see how large this community has really gotten in the past couple of years.
I'm going to make a bold statement today. The future of RISC-V has no limits.
For computer scientists, it's a dream come true.
RISC-V will go mainstream.
The future is already here.
The future for RISC-V is very bright. All these different communities are being attracted to that and then making it work in their domain. So that's how it's really spreading out across the future.
So whether you're interested in automotive or HPC, enterprise or embedded, there is going to be a place for you in this community to draw up the blueprint.
It builds a big collaborative community, as you see here. We have all these folks working together.
Being able to integrate sort of that hardware knowledge with the things you're doing in various software projects you're working on just gives you a more holistic picture.
So we have this ability to optimize both the hardware and software levels simultaneously and then make something fantastic.
RISC-V is not only a clean slate, it's a clean slate that has taken the lessons of everything that's gone before it and trying to do it all right.
I'm really excited to see where we go from here. We've gone from when I started having only 10 working groups to over 60 working groups.
RISC-V will be the bedrock of computing for the years to come, so the time to learn is now.
This is open to everyone. Let's just go and make an impact and make that change.
You're going to be seeing RISC-V around a lot.
It's going to be off the charts in 2022.
In challenging times, it's more important than ever to find new ways of gaining an advantage. That's why we provide the support our people and our customers need to thrive. Partnerships that are built on openness and trust. By sharing your challenges, we strive to give you the competitive edge in a global technology market. Solving complex problems together. Through innovation, commitment, and expertise. And creating high-quality technologies that empower our partners to succeed. At Imagination, our goal is to reach the very top of our industry, enabling our customers to build the world's best products and transform lives.
正在观看我们直播的所有的观众朋友们，大家早安，大家好。
Good morning, ladies and gentlemen.
我是今天的主持人
I'm your host, Joyce. Today, we are very grateful for your participation. Thank you for participating in this RISC-V Taipei Day held by RISC-V Taiwan, RISC-V International, and SEMI, and also Taiwan IoT Technology and Industry Association. This year, our focus is on the net zero emissions with focus on electric and autonomous vehicles. For this forum, we have invited international and domestic experts to share their insights on RISC-V. And so we are very happy to gather you around together to talk about how RISC-V architecture can be developed in innovative ways and have innovative applications in automobile industries. So we can also help the promotion of RISC-V proliferation in the future. At the back of the venue, there are several companies showcasing their RISC-V product applications and solutions. We encourage you to exchange ideas during the break with them, or maybe after the event as well. Today, we have a very impressive and exciting agenda. I am sure you will find it very fruitful. So at the beginning of today's agenda, I would like to invite Chairman Alex Wang from our organizer, RISC-V Taiwan, to give us an opening remark. Let us welcome Chairman Alex Wang. Distinguished guests online and also on site, you know that the E in semi means equipment and means material. But when we talk about semiconductors, it feels like it is the crown jewel for the tiara on the Queen of England. And of course, the crown jewel will be the CPU. So RISC-V as an architecture of the CPU, I think if we can, it is really a big honor for us to hold this event together with Semi. And at the beginning of today, or at the beginning of the development of RISC-V, people are still a little bit suspicious. But today, I can tell you, it is real, it is happening, and it is big. So a few big news to talk to inform you. Later, we have an speaker from Intel. It's a $1 billion investment. There is a $1 billion investment made by Intel for its ODM business and relevant infrastructure, and this Sci-Fi are participating in this project as well. And also, Intel is a leader in the computing industry for more than a few decades. That's a big news. So, a second news, shipment. We now have more than 10 billion CPU cores shipped. So it's much faster than the growth of any other types of CPUs. And as a computing platform, RISC-V originally was thought to be a rather small capacity, but actually it's much better than that. People originally thought there was no actual critical limit, but this year the Wujian 600 by Alibaba's development has already showed a very high performance computing application. So this is by the T-Head Semiconductor. And this year, the Hachette Forum, Uthether has announced a product with more than 1,400 RISC-V AI computing cores called the Bokria, and it is applied in deep learning, and it is a state-of-the-art technology. It is 15 times faster than any advanced GPU you can find in the market. So actually, there is no limitation for RISC-V architecture. When people think about open source, you think about freedom and freedom in scalability and extendability. So it actually develops very quickly and very flexibly. Today, we want to highlight the RISC-V application in automobile industries. The first wave of semiconductor, of course, is personal computer and then cell phone. But the harder thing today, right now, is, of course, other types of applications. And automobile industry is, of course, a fast-growing demand or market for semiconductors. And for us, right now, the Intel Mobile I is a big leader, innovator. It has a built-in 12 RISC-V cores. And Renesas from Japan also work with 2 major RISC-V IPs here today, NDs and Sci-5. So, in this fast developing stage of RISC-V, I am very honored to share with you. With Semi, I'm very happy that Director Su is here with us today, and I am really looking forward to much faster development in the future. I believe RISC-V will soon become the mainstream. Thank you. Thank you, Chairman Wang. I believe from today's events and conference, you will definitely know more about RISC-V's application in the automobile industry. Next, allow me to invite Semi-Taiwan representative, who is also the co-organizer, who is a big contributor of the development of RISC-V in Taiwan. So next, let us welcome Ms. Joanne Su, Senior Director of Semi-Taiwan, to come onto the stage and give us an opening remark as well. Welcome. President Alex Wang and Vice President Lin, good morning, distinguished guests, ladies and gentlemen. As a co-organizer for this event today, we are very honored, very happy. SEMI was established more than 50 years ago, and we helped facilitate many technology alliances. One is about sensor, one is ADA alliances for electronic system design. For electronic system design, RISC-V is a big topic. So actually, many years ago, we already began our discussion with Chairman Wang and started to talk about collaboration for something like this RISC-V Taipei Day. Especially now, the big focus is on the automobile industry. For auto chips, it's definitely a big demand globally, and around the world, businesses and government is promoting for electronic vehicle. And in the future, SEMI wants to work with RISC-V Alliance more, and especially in the field of auto chips. SEMI itself in July has a Auto I Master event. It is meant for a lot of semiconductor chip makers here in Taiwan. We provide you with a guide to help you understand the market demand around the world. And RISC-V is an open source design platform. So for many car makers, for many businesses in semiconductor, and especially IC designers, that gives you a lot of room for creativity. So SEMI is very honored to be here with you and participate in this trend. And so with our exchanges today, I look forward to more fruitful results and development here together, especially for RISC-V development application in automobile industry in Taiwan. Thank you so much, Senior Director Su. And next, we want to move on and thank you for your all support for RISC-V Taipei Day. And today we have invited many distinguished guests and experts from industry and academia here today. So I would like to invite some distinguished guests and speakers to take a group photo together on this stage. So first, Chairman Alex Wang, Vice Chairman Zhiming Lin, Vice Chairman Zheng Huang from our organizer RISC-V Taiwan Alliance, and Ms. Joanne Su, Senior Director of Semi-Taiwan, Mr. Tommy Ling, Senior Manager of Product Managing from Sci-Fi, Mr. James Su, Senior Principal and Application Engineer from Imagination Technologies, Mr. Vishak Rayapeta, Senior Technical Staff Engineer and from the FPGA Microchip Technology, and Mr. Tom Low, Analyst and Research Managers of Digitime, and Assistant Professor Jing Huang from the Information Engineering at National Cheng Kung University. Welcome. Please come onto the stage. You can take off your mask for the group photo. And please look at the cameraman in the middle, in the front. Thank you so much. Can we make a posture, a gesture together? So please raise your hand and show a V gesture. It means victory and RISC-V. So again, please look at the cameraman and let's celebrate 2022 RISC-V Taipei Day. Again, thank you our speakers and experts for joining us today. Thank you, distinguished guests. Now you can return to your seat and be seated. We will quickly move on to our keynote speech today. And this year, the organizer especially invites Ms. Calista Redmond, CEO of RISC-V International. It is the most influential international organization of RISC-V. Calista has attached great importance to the Taiwan RISC-V ecosystem since she took office. She especially recorded a speech for us to talk about international trends in RISC-V. The topic of her talk is RISC-V everywhere. So let's now enjoy the video.
Hi, welcome to RISC-V Taipei Day. I am so excited to be here. I'm Calista Redmond, CEO of RISC-V International, and I'm so pleased to be able to join you on this incredible culmination of community events and things going on around the world, and especially to our community here in Taipei. So thank you for joining us. You know, open standards and collaboration are what has brought the community together, what has overcome so many barriers of technology, of innovation, of finding and creating and crafting our own destiny. And the reason that this is so important, why now, is that RISC-V is bringing the power to the community. RISC-V is enabling you to chart your own destiny, to seize growing opportunities, to tackle the increasing number of compute challenges that we're facing around the world. And this is true not just in the number of challenges that we're facing, but how we're facing them. What we bring in our toolkit to continue to combat these challenges each and every day. And RISC-V is there. RISC-V is the center of this gravity, and we're seeing this growth off the charts. We've already seen more than 10 billion cores in market already, well on track with the analyst predictions. In fact, by 2025, we fully expect RISC-V to be in 10% of automotive CPUs. This is incredible. This is incredible progress when you think just a couple of years ago we were nowhere near this momentum. Why RISC-V? You know, the RISC architecture goes back decades, and version 5, RISC-V, is now the most prolific open instruction set architecture in history. And we say this because more and more companies have come on board with stakeholders around this spectrum. RISC-V enables a competitive design, a distinction beyond any other architecture. It's a very simple and modular approach to combating those compute challenges, and this gives you design freedom. This allows you to take open building blocks and layer on very highly competitive differentiated IP. And this is what we're bringing to the industry. So from a technical perspective, RISC-V is simple. It's a modular set of instructions that you can add on to just those instructions that are relevant to the challenge that you're wishing to overcome. This allows you complete freedom. And it is the freedom of working with incredible design partners around the world to share in that collective investment. That investment is in hundreds of millions of dollars that have been poured into RISC-V from startups to multinationals. The business opportunity. There would be no promise of RISC-V if there wasn't growing commercial opportunity. By starting with a royalty-free base building blocks and being able to add on to those both commercial and open extensions, This allows for choice, massive choice, and unlimited opportunity. This means that you have no constraints on the stakeholders you engage with, from development partners and supply chain all the way through to end users and customers. What does this look like? So yes, there are open building blocks that have been pervasive across the spectrum, primarily used in academia and research implementations in HPC, as well as incredible commercial opportunities. This allows for very domain-specific, highly differentiated solutions to solve a full spectrum of compute challenges. So think about what's on the right side of this. This means that you can work with so many different design partners to really get in there and be extremely competitive with differentiated IP that is available commercially. This is important as we continue to think about the great momentum that we're seeing around the world. But let's talk about Taiwan for a minute. One of our leaders in Taiwan, Andes Technology, one of the first RISC-V vendors to pass many of the safety and security standard protocols that we have seen across the automotive industry. This has enabled lots of great partnerships with Renesas, Andes, Sci-Fi, and Andes coming out with very competitive, differentiated IP to solve those performance challenges. There are many more collaborations going on, especially in the automotive segment, as we see with Imagination, Sci-Fi, Andes, Intel, Renesas, NSI, Texi, and many more. In fact, this has unleashed quite a renaissance in what we're able to do in automotive alone. We are expecting, again, 10% of the automotive market by 2025. In automotive, this means things like Mobileye from Intel. It means Andes with functional safety, Renesas and Sci-Fi on high-end RISC-V automotive applications. Imagination's GPU links with it RISC-V core for ASIL-B level designs. And again, safety critical. We are putting our most important workloads on RISC-V, and this is continuing to grow. In fact, Deloitte says the RISC-V opportunity is going to double in 2022 and again in 2023. So you are investing in a platform, a technology that is going to persist through time, because with that collective shared investment, it is all of us. It is all of us working together and individually and independently to achieve RISC-V success. This dedicated community has stakeholders all around the spectrum, from chip and IP providers, services like fabs and other things, I/O, memory and interconnect and storage, software. The software ecosystem is absolutely exploding. We also see a great deal of interest from the press and media as well as investors. But, it's those industries, it's that industry penetration that is really cementing RISC-V for generations to come. We're seeing it in our community too. We now have more than 3,100 members across 70 different countries, and this is continuing to grow month by month, quarter by quarter, across many of our different parts of our community. And we are working hard in RISC-V International to cultivate not just extensions that matter and are shared across numerous different interests, but also in industry-specific verticals like automotive, Android, HPC, and more. In fact, there is no limit to the number of places, the farthest reach that you can bring RISC-V. In fact, it's in space, it's in satellites, it's going to Mars, it's going to the moon. We see RISC-V in the most important workloads across a wide variety of industries. This year alone, we've already ratified 4 different extensions and ratifications, and these come in sets. So you see eTrace, RISC-V specification for SBI, engaging a firmware layer between the hardware and the operating system kernel. We see other UEFI standards being brought onto the RISC-V platform alongside all the safety and security standards as well. So look for the differentiation. This is beyond the vector implementations that we've seen already. We are continuing to grow our ecosystem. Our ecosystem includes not just the software layers, but the tools, the compilers, the performance, the CI and testing that is essential to bring high quality products to market. In fact, RISC-V is taking the lead across so many different areas and so many different domains, it's difficult to keep track of them all. But just as we encourage you to work together, RISC-V is working with each of these invested stakeholders around the community as well. Where you are looking for support, where you are looking to progress the state of the art, RISC-V is your home. We are your home to find support, development partners. Think of us as sort of the ultimate matchmaking for possibility, whether that is tackling a new compute challenge or finding a new market. This community has strength from the collective investment that we are all putting in this together. We are so honored to be part of this movement, this time, this very important moment in history as we engage that depth and breadth across the spectrum. So think about how can you bring RISC-V into your strategy, whether it is your team, your company, your own personal mission. Work on something you believe in. RISC-V is that something, and RISC-V is each of our guarded missions for long-term, durable, sustainable success. Enjoy this time together in Taipei. I look forward to being together with you again in the future. Please don't hesitate. Reach out to us, connect with us, share with us how you are progressing RISC-V to be the ultimate and the best computing platform for the next many generations of compute to come. We appreciate your investment. We are so excited when the community is able to come together like this, and I can't wait to be there with you again in person. So please stay connected with us, meet one another, make 10 new friends while you're here, and let's do this together. Thank you.
Thank you so much, CEO Callista. She is very passionate indeed. As she said, we are your home to find support. So you saw a QR code, so please don't hesitate. Scan the code. Anything you want to know, just scan the code and you can share it and discuss it with Callista. Next, for our next speaker, it is the Chairman and CEO of Andes Technology and also RISC-V International Association's Board of Director, Mr. Zhiming Lin, Frankwell Lin. Let us welcome Chairman Lin. And the topic of Chairman Lin's talk is RISC-V is unstoppable. So let us welcome Frankwell Lin. Thank you so much. Chairman, Vice Chairman, good morning. I am very honored today to share with you the mega trend of RISC-V. It is unbeatable and unstoppable. So let me first begin with an overview of the past few years' development. At the beginning of 2010, when RISC-V was just developed or just forming, when the idea just came out for RISC-V, I think there were a lot of doubts around different communities. When they first began promoting and designing RISC-V, there were many doubts indeed. And by 2015, when the foundation was set up, Andes joined in 2016, and eventually people started to see how many things RISC-V is promoting and doing. So today I want to highlight especially its work on hardware and software. On the slide, you can see I listed different items under hardware and software. At the beginning, it was RV32, and then eventually go to 64 bits. So in the past few years, I've listed all these new developments, and I will skip what Callista has already mentioned. You can see that eventually, gradually, it goes from instruction sets to CPUs to SOCs, and then the entire ecosystem built up. And applications are being used in more and more industries. And so if you look at the right-hand side, you see more software developments, more hardware developments, different chips from IoT, MCU to AI applications. So the possibility is limitless, and let us take a look at all the different possibilities. In the past year, from the second half of last year to the first half of this year, RISC-V International has rectified some new specifications in Q4 last year, rectified 16 new specifications and ESAs. And so these 16 new specifications represents 40 plus extensions modules. So we will take a closer look at these new specifications and extensions, but I want to highlight a few. The first one is vector. The second is scalar cryptography, and also hypervisor specifications. So what does these specification allow us? A lot. As Callista said, this year we rectified 4 new specifications. The first one is E-Trade, the second one is SBI, and then UFVI, and also ZMO. 4 new specifications. And these 4 allow us to set EFI standards from PC to a similar standard like UEFI, so we will have a common standard. So what does this mean? This means that RISC-V now values cost. I would talk about this a little bit more on a higher level. RISC-V not only values high standards but also low cost implementation, so its application is really far and wide. I was very honored to be a member of the board for RISC-V International, and in the process I saw all the work of the technical steering committee working group. There were experts around the world, top engineers, academic scholars, and also passionate individuals who participate in all the specifications and extensions. So this is the list of the extensions here. I've talked about ZMO on the top, and also the ZMO multiply-only extension, and also RISC-V cryptography extensions, 16 extensions plus others. And that means on the right-hand side, you can see more than 40 extensions. So 16 specifications result in more than 40 extensions. This means that in about a decade in the past, RISC-V continuously moving forward, developing, rectifying new specifications. It's still ongoing, because I'm seeing new working group all the time. So this RISC-V will only get more and more powerful. And the specifications, they're like Legos. It's modularized. You can choose to use which one you want to use, and you can only use it when you want to, when you need to. So it's very flexible. Personally, looking 20 years in the future, I can see myself still working on RISC-V. There's still a lot to be done. And I talked about, I want to highlight 4 specifications. The first one is vector. Vector was developed just so happened when AI is now a big topic around the world. So we need to handle a huge amount of data now, and it is better handled by CNN algorithms. And so just so happened Matrix multiplication and dividing are very important functions. So vector is the perfect solution. The implementation of vector, if you remember, the Cray supercomputer was as big as a room. Now, you only need one tiny chip, one tiny processor, one specification, and you will be able to implement it. So you can do a lot with this tiny little chip. And so, RISC-V vector can allow 1024 and 2048 and also 550, 256. For other specification, it was only 128-bit data range. So vector is really competitive. It can handle a large amount of data arrays. So RISC-V vector in the future for high-performance computer and also AI applications will definitely be a very promising specification. It will allow a lot of different functions. Now I would like to move on to hypervisor. It was rectified at the end of last year by RISC-V International, and it has relevant extensions. Hypervisor features virtualization for RISC-V. So virtual machine and physical implementations are now available for RISC-V. In the future, apart from deeply embedded applications, you can use it for much larger machine and in a much safer way. The next specification to share is scalar cryptography. So it's about coding and decoding. For this specification, RISC-V CPU now has another layer of protection. So many RISC-V CPU companies are looking at hypervisor and also scalar cryptography to see what can they do to implement it and compete with Intel and ARM CPUs. So this is an additional advantage if you want to compete with other CPUs. Scalar cryptography, once implemented, a lot of functional safety, other coding and decoding requirements will be available for RISC-V. Now, let's look at some of the designs incorporating RISC-V. And this research is by research group Wilson Research Group from Siemens. They found that 23% of ASIC chips and FPGA projects now incorporate or have already incorporated RISC-V in at least one processor. And also, another research from Tractica found that the total market for RISC-V IP software and tool is expected to grow a lot. So the market is expected to grow to $1.07 billion by 2025. I look at my keynote speech from the last RISC-V Taipei Day, and I found this slide. And this is a comparison between RISC-V and ARM. So our RISC-V beachhead was on the lower left-hand side quadrant for housekeeping, for offloading, for FSM. and we're moving up and moving right now. Moving up into the 3264 bits microcontroller, and we're moving to the right into data and vector. And for big little core, we found that when we compare with last year, it was originally an area where ARM dominates, and they're doing more in this area as well. So RISC-V products is also moving into many different quadrants, into different areas. And we often use Semical's research. With Semical's finding, we now know that Intel is investing a lot in RISC-V as well. In February, they invested in RISC-V, and so Intel is one of the in the board of directors of RISC-V International now. Intel now wants to join the RISC-V ecosystem as well. So if you need investment, if you want to develop RISC-V products, and your company or your subsidiary needs capital, then we can help you connect with Intel Capital. They have $1 billion of investment ready for RISC-V. In the past few days, we found this news from a local news agency. RISC-V is now going to space. And we want to congratulate Sci-Fi for being able to join the NASA project, and these products now is already used in some European satellites. So we're going to space. For the aerospace industry, we all have the opportunity to enter the industry as well. And for other industries like AI, edge computing, different types of computing, for smaller data to larger data volume, like automobile industry, I believe a lot of speakers will individually introduce you the applications in these various areas. Now, RISC-V has moved into multiple cores application. And there are two types of application. One is multi-core, and it will be in a cache coherent cluster, 16, 8 cores. But there are also many core application. It's what I said, the 1067 AI application. So using 1000 CPUs in AI is a very common application now. And today, later, my colleague, President Su, will talk about ND's products, so I will skip this slide. And this year, I also want to respond to our topic for this RISC-V Taipei Day about automobile industry. So ND's product portfolio is addressing importance for the automobile grade products. So starting from this year, we plan to launch 1 to 3 car products, car CPUs per year. So I want to talk about the difference between car use and the car automobile grade. So all ND's product is available for vehicle use, for automobile use. So you are very welcome to look at our products in this application, but for automobile grade, it's a bit different. Our President Su later will talk about this particular difference later. And now I would like to make some conclusions for you. First of all, RISC-V International Association keeps advancing RISC-V ISA and features standard in hardware and software as well. And of course, more advanced instruction sets, more comprehensive, low-cost computing specifications as well. Secondly, I kept promoting RISC-V in various locations, and I believe you will find that in the future decades, RISC-V will become one of the 3 mainstream industrial use ESA in the world. And Andes will continue to strive to be a leader for automotive-grade RISC-V in CPU IP. To conclude, I would like to say that I am very happy to see that we are able to hold RISC-V Taipei Day again. It's a great occasion, and this year is also Andy's year for launching RISC-V CPU IPs as SCLB, so basically automotive grade CPU. It will be our launch year. And this concludes my presentation today. Thank you very much. Thank you so much, Chairman Lin. And from Chairman's presentation, you will find that in 2025, the total market capital of RISC-V will be $1 billion. Thank you for sharing this wonderful news with us. We are looking at even more exciting speeches later, and I believe we are all anticipating to hear more. Our next speaker is very special. We have invited Mr. Gary Martz, Senior Director of Intel Foundry Services in RISC-V enablement. And however, due to the pandemic, unfortunately cannot join us in person. But again, he has recorded his speech for us, and we are very looking forward to it. So I invite all of you to again look at the screen, and let's enjoy Gary's speech.
Hello. I really appreciate the opportunity to present here at RISC-V Taipei Day. My only wish is that I was able to attend in person, as Taipei has always been one of my favorite cities to visit. I'm Gary Martz, and I'm a Senior Director in Intel Foundry Services, responsible for RISC-V enablement. My role is to collect customer and partner input on their needs for RISC-V, prioritize how we will engage the RISC-V community, and align Intel contributions to the RISC-V ISA and SoC specifications, as well as the RISC-V software stack development. The last time I spoke to the RISC-V community was at RISC-V Spring Week in Paris back in May. During that talk, I outlined the investments that Intel Foundry Services would be making in RISC-V specifications and software, as well as the investments that we're making in our global manufacturing capacity. I'm happy to report that we've made significant progress. We are continuing to ramp our hardware and software teams. We are providing leadership and roles in the RISC-V community where we can add value. We are continuing to evaluate applicants and make investments with our innovation fund. And we are continuing the development of our Horse Creek software development platform with Sci-Fi. We also continue to help drive the RISC-V commercial market through our partnerships with Sci-Fi, Andes, Esperanto, and Ventana to deliver CPU cores, chiplets, and fully packaged solutions. Even with this extensive investment and a broad base of industry contributions, building an ecosystem for RISC-V will take time and considerable effort. Today I will talk more about Intel Foundry Services and our role as a systems foundry, and how this will open the doors of existing ecosystems to RISC-V and will help continue RISC-V's extraordinary growth. The current foundry model enabled innovation at the wafer level, and we've been extremely successful. But the new era in chip making requires a reboot around our foundry model mindset. With the continued pursuit of Moore's Law and steady cycles of innovation, the data center rack is consolidated into a system, and systems are being consolidated into advanced packages. And these advanced packages are best built by a systems foundry. A systems foundry involves engaging with customers at multiple levels, from basic wafer manufacturing all the way up to helping define and implement desired system architectures and customized services. A system foundry includes 4 components. The traditional wafer aspect, continuing to be driven by Moore's Law, advanced packaging solutions, a chiplet ecosystem, and software that is tuned to the hardware. If you attended the Hot Chips conference in August, some of this presentation will already be familiar. It was at Hot Chips that our CEO, Pat Gelsinger, introduced Intel Foundry Services as a system foundry and discussed each of these 4 components. What I hope to convey today is why a systems foundry approach can be so valuable to the RISC-V community. The first component of a systems foundry is wafer technology and a pace of innovation defined by Moore's Law. Since our founding, Intel has thrived on the relentless pursuit of semiconductor invention and innovation as described by Moore's Law. This has enabled us to build more complex systems amid growing demand for more performant solutions. Today we have 100 billion transistors on a package, and our aspiration is to build solutions with 1 trillion transistors by the end of the decade. The challenge that this creates was predicted by Gordon Moore all the way back in the paper he wrote in 1965. He was able to foresee this day of reckoning, where it would be necessary to build larger systems out of smaller functions to deliver customized, heterogeneous solutions. We're moving from the wafer era to the systems foundry era, and Gordon understood the importance of packaging to enable this transition, and he said as much. Today, 2D and 3D stacking technologies give architects and designers the tools to further increase the number of transistors per device and will contribute to the scaling needed for Moore's Law. Advanced packaging is one of the driving forces behind our industry's future growth, including the growth of RISC-V. As an example, our embedded multi-die interconnect bridge technology, or EMIB, allows a designer to, paraphrasing Gordon Moore again, cram more components in the package. EMIB also enables the use of silicon from different process nodes and different vendors in the same package, allowing a designer to choose the best process node for that specific IP. Another example is our Foveros technology, which established the industry's first active logic-on-logic silicon stacking capability, creating the ability to add logic transistors in a 3rd dimension. Both of these advanced packaging achievements represent a notable change in how we deliver an increasing number of transistors per package. When used together, these technologies can achieve a level of integration never seen. For example, in our Point Vecchio GPU, we combined 47 active tiles of silicon in a single package, built at multiple fabs on different process nodes. This sets a new benchmark for advanced packaging and provides a roadmap for RISC-V solutions within existing ecosystems. Advanced packaging enables a new solution option and will help drive a chiplet ecosystem. A chiplet ecosystem is the 3rd component of our systems foundry. We are currently working with the industry to create an open chiplet ecosystem. And we envision that this ecosystem of chiplets composed together will be another key component in the continued growth of RISC-V. Earlier this year, Intel joined forces with Advanced Semiconductor Engineering, AMD, ARM, Google Cloud, Meta, Microsoft, Qualcomm, Samsung, and TSMC to launch the Universal Chiplet Interconnect Express Consortium, or UCIe. Just recently, NVIDIA and Alibaba also joined. The UCIe consortium is focused on a single goal, creating an open ecosystem for enabling chiplets designed and manufactured on different process technologies by different vendors to work together when integrated with advanced packaging technologies. Our goal is to help drive a single industry standard, similar to how we led the PCIe disruption of the 1990s. Coupled with what we call our Intel Chiplet Studio Suite, which will support designs leveraging x86, ARM, and RISC-V architectures, we see a sea of solutions customizing platforms for our customers to optimize on what best meets their needs, inclusive of different vendors and different fabs. I told a story during RISC-V Spring Week, and I'll retell it here because it highlights the 4th component of the system foundry. A little over a decade ago, 2 Intel executives made a bet, and the loser had to get on stage and read the statement written by the winner. One of our executives led our client hardware team, and the other executive led our software group. The hardware executive lost and had to read on stage that hardware without software is just heat. This is the 4th component of a systems foundry, software. Our Intel CTO, Greg Lavender, says software is the soul of the machine. And nearly all our customers benefit from the extensive software optimizations that are tuned to differentiated features and hardware that we provide. Today's solution comprised silicon plus software and also software as a service. Very few companies have the experience and capability as Intel in silicon plus software. To bring the systems foundry approach to life, we will lead with a software-first mindset at every layer. And we're bringing some of this leadership to RISC-V. My colleague from our software group, John Hingeveld, was just recently elected as the vice chair of the Privileged Software Horizontal Committee in RISC-V. At the top layer of the software stack, market-making technologies are built on top of foundational and middleware software. Here, we will deliver new security services and solutions to meet the growing needs of our customers. The middle layer of market differentiating software consists of a large set of tools, libraries, languages, and frameworks, all sitting atop foundational software at the OS and virtualization layer. We use software and hardware technologies to deliver immense value into the ecosystem, providing a stable software interface for customers to develop solutions well in advance of hardware. We then empower it, accelerate it, and secure it with the hardware underneath, which altogether drives the chiplet ecosystem. And we're bringing this software-first mindset and creating value for RISC-V through our contributions to the software ecosystem. The continued pursuit of Moore's Law, advanced packaging, chiplets, and software-defined silicon-enhanced solutions are the four key components of a systems foundry. Systems Foundry is driven by a combination of technological demands, economics, and fundamental physics. With the Systems Foundry model, we offer secure supply, open platforms, and composable solutions through wafers, advanced packaging, chiplet technologies, and the system software that is required to overcome fundamental limits and meet the industry's insatiable demand for semiconductors. During this transition, from a system on chip to systems of chips, we need to optimize everything from the system and software architecture to how we do manufacturing and test. We need to think about everything in 3D, from die construction to assembly rules to verification and sign-off, to our automated post-silicon verification and test flows. As a systems foundry, we will drive an open ecosystem for RISC-V solutions, and we will optimize RISC-V PPA on Intel 16 and Intel 18A. We also need to drive an open ecosystem for IP and interconnects between chiplets. And we need to develop applications and system software to maximize the specific and aggregated performance of the solutions that we're building. Additionally, Intel Foundry Services will offer advanced silicon services to help our customers bring their RISC-V solutions to market. Normally, this is when I would open up for questions, but since this is a recording, unfortunately, this isn't possible. However, if any of you plan to attend Intel Innovation, being held September 27th through 28th in San Jose, I'd love to meet you in person. I will again be presenting our vision for RISC-V and our Systems Foundry, and also participating in other activities at this event. Thank you again, and I hope to see you all soon.
非常感谢 Gary 的分享。Thank you, Gary, for your sharing with a lot of information, important information. 所以现在呢，
Thank you so much, Gary. Gary is actually online with us. So in the panel discussion later, Gary will also join us online in the panel discussion and interact with our live audience here in the conference room. So as Gary said, we will be able to meet remotely online. Next, we have invited Mr. Charlie Su, President and CTO of Endins Technology, one of the first company in Taiwan who started promoting RISC-V and one of those who contributed the most. So President Su, Dr. Su, is however unable to join us in person, so he has also recorded his speech. So again, I will invite you to look at the screen for his speech. The topic of his speech is how RISC-V helps your competitors. Very interesting topic indeed. So now let's
大家好，我
enjoy
是
the
Charlie
speech.
苏宏蒙，
Good morning.
金星
This
科技
is
CTO
Charlie
兼
Su,
总经理。
the
今天要跟大家讲的题
CTO
目是
of
How RISC-V
NDS.
helps your
And my
competitors。
topic today is how
这题目有点
RISC-V
呛，
helps
但
your
实际上
competitor.
要
It
讲
sounds
的
a
就
little
是
bit
How
provocative,
RISC-V can
but
help your
actually what I'm
application。
trying to say is
那我
how
们今天会讲
RISC-V
RISC-V
helps your
这一些这个应
application.
用带来
And
的优
today I
势
will talk
跟
about some of
一
the
些应用的范
advantages
例。
of
首先我们来
RISC-V's
讲一下 RISC-V
application
跟
and
NDIS。
its use
RISC-V
case.
Foundation
Talk
在
about
2015年
NDS
成
and
立，那
RISC-V
会员
first.
快速
RISC-V
成
was
长。
formed
那
in
它的 ISA 从
2015,
基本的
and the members
IMAC
continue to
跟 floating
grow,
point
and
每
its
年都
ISA
增加一些
from
的指令，
the
那到
MACFD
今年去
to
年
15
一
new
年就增加了
extensions,
15个这个
and
新的
last year
extension，
there
所以
were
指
a
令是
lot
非常
more
丰盛的。那它指令
extensions.
的最大优
And
势
the
就是
biggest
open、compact
advantages of its
跟
ISA
extensible。
is
因为
open,
open 的话，
compact,
大
and
家才可以
extensible.
会做处理器也都可以去做。
Being
compact
open means you
带来
can
好
do a
处
lot
就
of
是
things
处
with
理器
it.
做出来
Being
是
compact
比较
means
精简，
that
而且
your
可上又比
processor
较低的。
is
那
smaller and
extensible 的话就
lower
可以去
cost.
address 这
Extensible
个
means
domain
that it
specific
can address
acceleration 需要的一些特
domain-specific
殊指令。
accelerations.
那 RISC-V 的 vision 呢，
The
就
vision
是
of
希望它能够
RISC-V
用在
is
所有的
to
computing
be
devices。
used for all computing
好，那
devices.
金星呢，我们在
And
2006年成立，
NDS was
在
founded in
2017年
in
上市，
2005,
一直到
and
今天
the
我
IPO
们都
for
是
us
纯
is
粹的 CPU IP
2017.
公司。
Until today, we
那我们
are
开发了
pure-play
3代
CPI
我们
IP
自由
vendor.
指令集
We
，V1
have
到 V3， 那
developed
10个以
3
上的这个
generations
的核，
of ISA from
然后还有
V1
包
to
括
V3,
相
and
关
we
的
have
软体。
developed more than
那
10
我们的
cores
GCC
and
跟
relevant
Linux 也都有
software.
upstream 上去。
And our
那在
we have
2015
many
年，我们
options
注意
as
到
well.
RISC-V， 那
In
它
2015,
的
we
指令的优势，特别是
we
compact 跟
identified
extensible，
the potential
跟我
of
们的
RISC-V and its
V3 很
advantage
像。
towards its
然后它的
compact
vision
and
呢，跟我们
extensible,
NDIS embedded
just like
又
the
是
spirit of a
非常
company.
契合。
And
所以我们第5代
so
的我们
we
的指令
developed
新的
the
指令集
V5
V5
ISA
就采取
based on
基于这个
RISC-V
RISC-V， 然后再加上 NDIS 的
with
extension。
NDS extensions.
那同时呢，我们也加
At the
加
same
入
time,
那
we
个
joined
RISC-V， 成为
RISC-V
RISC-V 的
International,
founding
become its
premium member。
founding
那我们
premium
在
member.
董事会
And we
跟
also
GSC 这
joined
边，我们
its
都
board
占
of
有一席之
director
地。
and
那我们
TSC,
的 member
and
也
we
是非
are
常 active，
very
在 task group
active
扮演一些
members
chair 跟
in
co-chair 的
various
角色。
task
好，那回到我
group
们
as
的
chairs
今
and
天主题，
co-chairs.
那我们这边做一
Now
个对
back to
application
our
做一个
topic
很 rough 的
today.
一个区分哈。
We
那我
will
们用
give you
了
a
4个
very
象
rough
限哈。那在水平头这
categorization
边，左边是 code
of
sensitive，
different
右边是
application.
performance driven。
And the horizontal
那下面
is
是 deeply
code
embedded，
sensitive,
上面是
and the
general
right hand side
purpose。
performance
那这样我们就
driven.
有这个
And look at the
左
bottom
下
is
这边
deeply
embedded
embedded, and on
controller，
top is
像一些
general
state
purpose.
machine 啊，
Lower left
比如说
corner,
touch，
it's
或者
embedded
是说
controller
这
like
个 sensor
FSM
hub，
and
那
protocol.
或者是说
And
WiFi Bluetooth。 这种用来 run
it's
embedded
used for
protocol
state
stack
machine control like
接
touch
下来
sensor hub,
在这
and
个
also
左
some
上就是
embedded
MCU
protocol
NPU，
stack for
还
Wi-Fi
有
and
这个
BT.
AIoT，
And left
因
up
为 AIoT
corner
也
you
是一
can
个
see
general
MCU
purpose 的，
and
那需要 code 再
NPU,
去做。
general purpose MCU,
第一步的
NPU,
programming。
and AIoT.
那在右下这边我们称作
Lower right corner,
accelerator，
you can find
包括像 low
accelerators
speed 的
like
compute，
low speed
传统的
computing,
DSP 啊，audio
traditional
voice，
DSP,
或者是
audio and
slow
voice,
的
and
video 跟
also slow video and image
processing，
sensors.
还有 high speed 的
And for
compute，
high-speed
像 AI
computing,
machine
it
learning，
includes
还有
AI, machine
HPC，还有
learning,
这个快
high-performance
人
computers,
位比较高
fast
的这个
video.
video。那还有这个多 channel 的一些平行
It's
处理啊，
there's
像
also
high 的
many
storage
channel
或 5G 的
processing like
networking。
heightened storage,
那
5G
最后上面的
networks.
话就是 application
If you look at
processor，
the upper
包
right
括这
corner,
个
it's
rich
application
GUI 的这
processors
个
like
像手
rich
机、
GUI
平板这种
for
环境，
cell
或是
phone
data
and
center
tablets
application 的
and
server，
data
还有 general
center
purpose 的 Linux。
servers, and also
那
general
RISC-V
purpose
在前
Linux.
面两个 rich GUI 跟 server 这边。
RISC-V
还有努力的空间，但是
has
在
some
general
room
purpose 的 Linux
for
这边其实
improvement
已
for
经
rich
相
GUI
当好
and
的
surface,
成绩了。
but for
那大家
Linux,
会
there's
觉
a
得
lot
说，
of
那
good
这样
results so
这个
far.
auto 车
You
用
may feel that for what about auto? What about auto SoC? Actually, for auto SoCs, it covers the entire scope, like tire pressure, auto MCU, and ADAS system, and also infotainment. Auto SoC with RISC-V has a big advantage. It's that it's functional safety based on ISO 26262. And here I list some application requirements for processors, some key requirements. Of course, not every application requires all these requirements, but these are just some basic ones, like compact, low power, good integer performance. These are the advantages of classic RISC-V ASAs. And then for caches and local memory, it needs to work with DMA. And I also talked about efficient low data rate computation and high data rate computation as well. Very efficient and powerful. And small code size is very important for many applications because the program codes will be stored in this chip and has run with caches. So if begin with 32 KB, it will feel the cost, and when it goes to 512 KBs, it can reach it can be even bigger, several megabytes. So small code is really important, and for Linux and RTOS support, it's also important. I will talk about more about these in details later. And flexible interfaces, pre-integrated performance are also requirements. And these processors include one subsystem and 4 CPU subsystems to proliferate like bus are all included, so we can help you with your SoC implementation. For some customers, they are very innovative. They can use our platform and take the core, take the most important part and construct their own SoCs. Like the lower right-hand corner, you can see a 5G Open RAN small cells application. They took 2 of our bus metrics and made a 32 bus metrics and made a very powerful SoC as a result. And the other example is the extendable baseline components. Extendable Series Phi has a good advantage, and Andis was really good at this. We have an automated ACE Copilot to help customers link. And then let's look at RISC-V code side. The baseline is IMAFD plus the C16 bit with bit manipulation. It is rectified. And for RISC-V cosine reduction task group, it is today for NDSV5, we have, based on the RISC-V baseline and also our codens extensions, we are able to reach 17% more reduction than the baseline. And if we put baseline with the ZCE, then we can reach 12% reduction. And when the ZCE was rectified, we will include it as well. So we can reduce even better. And for low-speed computations, RISC-V has the RVP extension. It is something that NDs donated from our DSP and SIMD. It is very compact and efficient for implementation. For endpoint processing, it is really very efficient. And when we compared with the Cortex-M DSP single issue M4 and dual issue M7, you can see the result for RV32, the D25F and D45 versus M4 and M7. You can see the DSP library in orange bar. We have more than 50% for DSP library speed up. And for CFR10, the image transformation AI benchmark, we have more than 3 times of speed up. And for RV64 application, because Codex-M doesn't include 64, so we compare ourselves, and we can see up to 25% to 50% of speed up. For high performance MCU and NPU, RISC-V is also doing very great. For HP Micro HP 6000, it is a DSP capable in real-time MCU. It uses 1 or 2 800 MHz D45 32-bit, and it has SD-RAM, CAN, and USB interfaces. Its applications include Industry 4.0, smart home, and also payment kiosks. For Renesas RZ5 MPU, it is a Linux-capable MPU. It uses 1 GHz NDIS core and X45MP and 64 bits. The interfaces include DDR4R4 and Gigabit Ethernet and CAN. Applications include gateway, industrial IoT, and security. The power consumption is usually harder to compare. However, it just so happened that Renesas RZ5 and RZG2UL are of the exactly same chips. Its CPU are the same 62K L1 cache, 256K cache, and with the same DDR. So Renesas took some use cases and test cases, and were able to compare from case 1 to case 3. The CPU and the RAM's use rate was lower. And then for MDX45MP, we are able to reach more than 10%, around 10% of power saving. And for the fourth use case, for CPU and GPU, you can see we can save a lot more, almost 50% of power reduction. More than CA55. And let's look at the architecture for high-speed computations. For the same, it is a scalable multi-cluster architecture. Inside this is it has a control processor, many clusters, and it runs Linux, RTOS, and also applications to control the cluster. And there's a global memory and multiple processing elements. So for the processing elements, if you don't like, apart from PE, there's usually a hardwire engine on the upper right-hand side and to accelerate. And of course, there will be a compute processor in the PE as well. And so there will be a very powerful computing unit to handle like algorithm and standards, something more dynamic change. And it also requires extendable ISAS interface, so it can combine with the hardwire engine. And for the memory subsistence, it allows more communication. And for NX45MP, either 1 core up to 8 core, it is already applied in many different environments as a control processor. For NX27V, it's a compute processor, very popular. More than 10 customers are using this in their projects. The most powerful part is the support. It supports RISC-V extension from 128 bits to 512 bits for both VLAN and also CSIMD 512 bits. So it is this is only Andes can do. This is something that only Andes is doing right now. And if you look at the chart on the right-hand side, from 512 to 128, the speed up is very linear. And if you compare to the area ratio, the speed up is really much bigger, the speed up ratio, so it's very efficient. And for as I said, we support customer extension. We have a tool allowing you to add extensions easily. So the merit of this architecture is combining separating control processor and compute processor. So not every core requires a Linux. You can separate them. So for the overall computing, and it will be most optimal. Moving on to FUSA. Before launching FUSA products, you need some homework to do. And for NDs, in 2010, we have already passed ISO 9001 QMS certification. We continue to maintain it. And for ISO 26262 development process certification, we also pass it. And is also certified in 2020, about 2 years ago. We are certified for the SLD level process. That means after the certification, we are able to develop SLA to SLD grade products. The certification is by SGS-TUV. And the plan for us is we want to develop one SIL compliant processor per year. Our first FUSA processor is N25SE. It is based on our very mature and popular core, that is N25F, with some enhancements. It is a RB32 processor. It has an indigenous instruction with ND star V5 extension. Its pipeline is the classic one, the 5-stage pipeline. It supports code size reduction, code dense, because code is very sensitive for auto application. And also stack safe, we have PMP and ECC features. And also our enhanced features are there to prevent systematic and random hardware failures. The N25F-SE is to be as ISO 26262 compliance, and it is waiting for final certification by SGS. This product, apart from standardized RTM and documentation, it also requires the safety package, including safety manuals, like assumption of use, safety architecture, and so on. These are standards. And also the safety analysis reports like DFMEA and FMEDA. And once this product is launched, we of course need a lot of partners with certified rules, from compiler to Misra tool to runtime environment. We have partners working with us in all these different areas. And for N25F-SE, it is already very stable and already used in many automobile applications, from in-cabin radar on the left-hand side to detect driver tiredness or whether there's a baby on board, and the way to the middle, auto TDDE, touch panel control, and to the right-hand side, auto general purpose MCU. So it's used in all these applications. And in car use SoC, this very popular product N25-SE is really widely used. And so I want to talk about ready or not ready. So a seal ready versus a seal compliant. These are two different concepts. I say ready, not ready, because I know ready means ready in English, but in Chinese, it doesn't really mean ready. If you remember, about 2 decades ago, there was TVs called cable-ready TVs, but actually you need a TV box to actually watch cable programs. So that was not a real ready TV. So a ready processor means that your SoC team still need to do a lot of work. And so it's tedious and it's easy to make mistakes because you didn't design a processor yourself. To conclude, I want to say that RISC-V has become a leading choice of processor for SoC and computing platforms in the past few years. It's already one of the best choices, usually the best choice. And it's because of its openness and also its technical advantages. Its ecosystem is developing very quickly. I believe it will continue to grow even faster in the future. And this is based on RISC-V ISAs and many extensions and the RISC-V ecosystem. We are happy to share the RISC-V advantages with you from edge to cloud. So on the right-hand side, you can see many applications from mobile to IoT to automotive to storage, 5G networks, and data centers. We have customers in all these areas using our CPUs. There are other customers who are not willing to be associated with a particular application, but we still list their logos here. But anyway, you can see that the application is highly diversified. So once the processor is auto certified, it can be used in many different automobiles and different applications. So if you're not using RISC-V now, I suggest you look at it. Maybe you can use RISC-V for your next SoC. And this is very happy to help you and to explain RISC-V to you. And so to conclude, what can we offer? We have 17 years of experience, more than 300 customers, more than 80,000 NDSide IDE users, and we have customers producing more than 10 billion SoCs. So the final words of my presentation, I want to give you a slogan, but it is something we used before joining RISC-V, since we're talking about cars today. So we want to drive innovations with NDs embedded. Thank you.
好，我们非常感谢总经理精彩
So once again, I would like to thank Senior Manager Lin. So during the panel discussion, I do believe that the speaker will be with us at the panel discussion. So please make sure that you stay until the very end so that we can hear more from him. And I believe that later we will hear more and more discussions and presentations. Now we would like to invite Tommy Lin, Senior Manager Product Marketing from Sci-Fi. Please, welcome. So his topic will be Sci-Fi RISC-V processor for automotive and safety critical applications. So once again, I would like to give the floor to our speaker. Ladies and gentlemen, good morning. My name is Tommy. So today I will be talking about the automotive and safety critical applications. Actually, 2 days ago, we just launched our Sci-Fi automotive products. So first of all, I think we should talk about why RISC-V will cater to the trend of the industry. Actually, at the very beginning, RISC-V is very different from the technology we've seen in the past. In the past, we've seen Bluetooth and other standards. Actually, on the standards, all manufacturers are doing their things. However, for RISC-V, we have this open format. So when this open standard was launched, a lot of the companies in the world would join forces in the development on RISC-V. It's more open and freer, where everyone can participate. Actually, since its launch in 2015, we saw the establishment of RISC-V Foundation, and then from MCU to HPC, you can see that RISC-V is developing at a very, very high speed. And also you can see in semiconductor industry, a lot of the leading companies are also devoting themselves into the development of RISC-V. We can see that the growth this year is very fast. We have more than 3,200 members in RISC-V International, and the ecosystem saw a strong and robust momentum. In 2010, our founders actually created RISC-V, and then in 2015 they formed Sci-Fi. At the moment, with our 7 years of experience, we've worked with our clients, and we have more than 3,000 design wins, and we have more than 100 company partners, and 8 out of the 10 top semiconductor companies work with us, and we have more than 500 employees around the world. In the second quarter of this year, we have finished the second round of fundraising, and our valuation stood at 2.5 billion. And if you look at our global presence, you will see that we have footprints in Africa, Asia, and America. And especially in America, you can see our footprint in California, and we also have footprint in France and Taiwan. So we have more than 100 PhDs, and our team is highly experienced. So these are the previous products that we've launched. So we went from the traditional CPU, for example, the Sci-Fi Essential series, we have 32 and 64 bits. and it was used for MCU, IoT devices, or real-time control. We also provided a lot of customization, so it was a more mature application. And prior to that, we also made better plans for our products, so we then launched the Sci-5 Performance. So it was addressing the high-end applications, for example, the high-performance computing or server. And also we have this AI machine learning core. So these are the developments that we've seen with Sci-5, be it functions or technologies. We are trying to better ourselves day by day. And like I said, we were focusing on the we have been focusing on the automotive market. So you can see that in the vehicles nowadays, they have been equipped with more and more capabilities. Then you see the EVs and autonomous driving, or the ADAS. You will see that these functions, these features will be more common in the future. So a research institute actually surveyed and researched into the 2020 to 2030, and you can see the CAGR of SoC for automotives will be 19%, and MCU will be 9% growth. So now what you can see is that you will see the CPU computing power has been increased and enhanced, and because in the future more functions will have to be carried out. So the automotive architectures are also evolving. Therefore, the HPC capabilities will be high in demand, because in the past, the traditional CPU would have to work hand in hand with other technologies. However, now you will see a model of the traditional computing. It would be more compatible with each other, and the computing center will require higher performance. And also electrification, the CAGR would be 20% for 2020 to 2030. Now, if you look at different roles in the automotive industries, be it CPU or the chips, you will see them having different requirements. So if you look at silicon vendors, they would like to have optimized PPA, and they also hope to have flexible IP and business models. At the same time, they hope that they will have more flexibility with their business model. And long-term support is also very important to them. This is very different from the past. At the same time, they also require best-in-class functional safety. For the automotive supply chain, if you look at tier 1 vendors, they will have more options. They can customize their products according to their demands. Of course, they will have to align with the functional safety standards. And for the brands or the OEM vendors, security comes first, and software, more portability are also very important to them. If they are running on a same structure or a same architecture such as RISC-V, they will have more flexibility, and they can use the same development tool to work on their software and programs. And with the software and the chip and system customization, they will be able to create the differentiation and they can have more cost-reduced options. Over the past 2 years, you can see the automotive development. For example, if you look at Renesas, Renesas has worked with Sci-Fi. We worked in different fields, and we also worked with Mobileye, and we also have these working together. And we also worked with machine learning manufacturers, and we also have projects backed by the government. And if you look at the tool manufacturers, all the hardware, software can be combined under the RISC-V system. Now, if you look at these graphs, currently we look at the we're focusing on the design of the domains. So they try to connect the bus under the architecture. In the future, it will be more like zonal architecture. So we would go from domain architecture to zonal architecture. So in the central system, the computing will be carried out there. So if you look at the history of the computing history, when the hardware can have higher computing efficiency, the software and hardware will continue to run on the hardware and then provide better functions. So for the automotive CPU, you can see the different requirements as we list here on the left. For example, 32-bit embedded CPU, and then we also have 64-bit high-performance CPU. At the same time, some capabilities will rely multi-core or multi-cluster combinations. And vector computing is a very important feature of RISC-V architecture. If you look at the system side, I/O virtualization and security, for example, SCOB and SCOD, and security, all of these things will have to align with the standards and the requirement. Now on this slide, please take a look at the bottom left. In Sci-Fi, we have many people working on the automotive safety, and we have many industry domain experts. So be it architects, safety managers, product managers, or functional safety designers, we can see that Sci-Fi has gathered the best talent to form a team. And our product portfolio is very complete. You know, the automotive products will last, so we devote a lot of the requirements and gather them together. So be it the 32-bit or the 64 bits high performance, or the embedded CPU, or be it SCOB or SCOD. In terms of the development, our technology can offer more and more options, different options. So, for example, we have split lock and dual core lock step. So if you look at these across our product lines, you can see we have multi-core cluster vectors and virtualization and security. All of these are the advanced automotive features offered from our CPU side. of course, the support from our ecosystem is very important because CPU alone cannot do all the work. You have to connect everything together. For example, compilers, real-time operating system, or STL, virtualization, or safety consultancies. All of these are very important elements in developing our future technology. And on this slide, we are going to talk about the ISO 26262 standards. So I think that if you are working for the electric vehicles, you might know this very well because functional safety is very important. We have to be prepared for our clients' demands and needs. We have to make sure that we can help them align with the standard. So our compliance will have single core or STL for ASIL-B, and we also have redundancy elements. And like I said, for SIL-D, we have different options. And we also offer a safety package. So like I said, across the RISC-V ecosystems, we have a lot of partners. SiFi works with them to develop the RISC-V ecosystem, be it the STL or safety consultancy or virtualization. All of these are the technologies that we're working with our partners. So those were our product series, and the 32 embedded will be launched very soon. We have SIL-B for split lock, and the clients can customize their options. And for the AD, they could have dual core lockstep. So if you also want SIL-B, however, if you have more, you want to see more a better efficiency for the performance, you can also choose to go with our other plans. So in the future, we also will, and next year, we will launch the automotive versions. So the vision, sensors, and sensor fusion will be launched next year. In 2024, we will have S7 AD series, which will be dedicated to safety islands for automotive SoC. And on the top, you will see our other products that will be launched very soon. So if clients would want to have higher computing performance, they can choose the products that we will launch next year. So if you look at our portfolio, the automotive are actually very different from other series. It's more vertical, and you can have simple and complex. So it's a very diverse range of products series. Now, the SiFi automotive standards and specifications are very complicated. However, they can also be used for the medical field and the industrial and automation applications. So I would like to conclude here. SiFi offers a wide range of products, be it the small feature to functional safety from SIL-B to SIL-D, or the RISC-V ecosystem. SiFi is your best partners to work on all of these products together. We can help you integrate with your technology. So this ends my presentation. Thank you.
Thank you so much, Senior Manager Ling. Thank you, Senior Manager Ling. And I believe those in the industry already feel the strong wave of RISC-V. And you will understand now it's a way for the future, and we need to pay attention to its latest development. We will now approaching the break. But before that, I would like to share with you that if you're interested on behalf of your company or as an individual, you are very welcome to scan the QR code on the screen to join RISC-V Taiwan for free. I believe we can complete the RISC-V ecosystem in Taiwan together. So now we will have a break. You are very welcome to take a look at the RISC-V exhibition at the back of the venue. They have prepared we have prepared watch a video for you to watch on the latest development of RISC-V. Please return to this conference room in 15 minutes. After break, we will continue with the exciting agenda. And I will remind you when we are about to start. So enjoy your break. Thank you.测试麦克风测试麦克风测试 testing microphone testing 1 2 3 4 5 6 Okay, thank you.
It's just wonderful to see engineers congregating together.
I'm really excited to be here at the RISC-V conference.
It's fantastic just to see how large this community has really gotten in the past couple of years.
I'm going to make a bold statement today. The future of RISC-V has no limits.
For computer scientists, it's a dream come true.
RISC-V will go mainstream.
The future is already here.
The future for RISC-V is very bright. All these different communities are being attracted to that and then making it work in their domain. So that's how it's really spreading out across the future.
So whether you're interested in automotive or HPC, enterprise or embedded, there is going to be a place for you in this community to draw up the blueprint.
It builds a big collaborative community, as you see here. We have all these folks working together.
Being able to integrate sort of that hardware knowledge with the things you're doing in various software projects you're working on just gives you a more holistic picture.
So we have this ability to optimize both the hardware and software levels simultaneously and then make something fantastic.
RISC-V is not only a clean slate, it's a clean slate that has taken the lessons of everything that's gone before it and trying to do it all right.
I'm really excited to see where we go from here. We've gone from when I started having only 10 working groups to over 60 working groups.
RISC-V will be the bedrock of computing for the years to come, so the time to learn is now.
This is open to everyone. Let's just go and make an impact and make that change.
You're going to be seeing RISC-V around a lot.
It's going to be off the charts in 2022.
challenging times, it's more important than ever to find new ways of gaining an advantage. That's why we provide the support our people and our customers need to thrive. Partnerships that are built on openness and trust. By sharing your challenges, we strive to give you the competitive edge in a global technology market. Solving complex problems together through innovation, commitment, and expertise, and creating high-quality technologies that empower our partners to succeed. At Imagination, our goal is to reach the very top of our industry, enabling our customers to build the world's best products and transform lives.
It's just wonderful to see engineers congregating together.
I'm really excited to be here at the RISC-V conference.
It's fantastic just to see how large this community has really gotten in the past couple of years.
I'm going to make a bold statement today. The future of RISC-V has no limits.
For computer scientists, it's a dream come true.
RISC-V will go mainstream.
The future is already here.
The future for RISC-V is very bright. All these different communities are being attracted to that and then making it work in their domain. So that's how it's really spreading out across the future.
So whether you're interested in automotive or HPC, enterprise or embedded, there is going to be a place for you in this community to draw up the blueprint.
It builds a big collaborative community, as you see here. We have all these folks working together.
Being able to integrate sort of that hardware knowledge with the things you're doing in various software projects you're working on just gives you a more holistic picture.
So we have this ability to optimize both the hardware and software levels simultaneously and then make something fantastic.
RISC-V is not only a clean slate, it's a clean slate that has taken the lessons of everything that's gone before it and trying to do it all right.
I'm really excited to see where we go from here. We've gone from when I started having only 10 working groups to over 60 working groups.
RISC-V will be the bedrock of computing for the years to come, so the time to learn is now.
This is open to everyone. Let's just go and make an impact and make that change.
You're going to be seeing RISC-V around a lot.
It's going to be off the charts in 2022.
A warm reminder, our conference will begin quickly in 2 minutes, so please be seated and get ready for the rest of our agenda. And please turn your mobile device into electronic or silent mode. Thank you very much.
位现场的嘉宾朋友们，当然还有我们线上的观众朋友们，欢迎大家再次回来到
Welcome back to the 2022 RISC-V Taipei Day. And for the rest of the agenda, we are still going to listen to some very exciting speeches. So we will surely learn more about RISC-V and its applications in different areas. And soon, we will later begin with our panel discussion at the end of all the speeches. And so for the next speaker, we have invited James Shi, Senior Principal and Application Engineer of Imagination Technologies. So let us now welcome Senior Principal Shi. Chairman Wang, Vice Chairman Lin, distinguished guests, ladies and gentlemen, good morning. I am very honored to be here on behalf of Imagination Technology to share with you our products and our latest RTSM 2200 RISC-V CPU. First, allow me to share with you our product portfolio for IP. From the left-hand side, it's our GPU products. In the market, our GPU products are rather popular and enjoys good reputation. From the first generation 3D graphic cell phone, Android cell phone application, and also Apple cell phone, they at the beginning of their product they used Imagination GPUs. So our product continues to be applied in many different smartphones, and then DVP and set-top box and OTT, even in data center area or data centers. For GPU products, we have three product lines. On the left-hand side, it's XC, XM, GPM GPUs, and they're more cost-efficient products, mostly used in cell phones now. In the middle, it's XT GPU. It's more about function and performance. So it's usually used in flagship premium cell phones and also data-centric applications. And then the third type of GPU, XS GPU. S means safety here. So it's mostly for the automotive industry, for e-mobility. And then moving on to the right-hand side, the AI products. Imagination continues to work on neural network accelerators in an A. So this is to accelerate machine learning capacity. And lastly, for connectivity, we have developed EPP, Ethernet Packet Protocol Processor. So it is for Ethernet package processing. It is highly powerful, from low bandwidth 3 gigabit per second to more than 200 gigabit per second. So it can cover all these bandwidth, and it features QoS functions. So with the support of hardware for switch or routing and NAT latency. So for the 25 gigabit board, the latency is only 0.2 microsecond, very, very short. That's how we can make sure that the package is transferred in a very timely manner, very low latency. We mentioned functional safety here at the bottom in the purple box. For M&A, we has a product for functional safety. So a good option for automotive applications. Imagination continues to grow in our products and also in our technology. So this year, we have a new product line that is RISC-V CPUs. Now, it is ready for launch. So customers can already acquire our products in the market. We have two series. One is real-time CPU family. The other is high-performance CPU family. So the green boxes in the middle. We have a product dedicated for functional safety as well. I mentioned this because for the auto market, especially for ADAS and AV, the e-mobility applications, autonomous driving or ADAS, in the past, the electronic devices are built in a distributed way, but as Sci-Fi mentioned, gradually in the future, the electronic system will go into the centralized or zone architecture. Being centralized means you need to have a very strong SoC or SoC platform at the center for computing, for the car, or for displaying configuration. So that means heterogeneous computing will become very important. This type of structure or architecture is combining different processors. These processors using different instruction sets, but heterogeneous computing will be able to combine them and achieve the highest efficiency and performance. So imagination focus on this. We found the potential in this. So in heterogeneous computing, we have developed different products for different applications, especially for the automobile industry. We want to provide a one-stop solution for auto market. So this is what I was talking about, heterogeneous computing. The demand is getting higher and higher now. AI and machine learning is developing fast as well, and the demand comes from that. It needs better and better performance and efficiency. And also, we need to look at power consumption in AI and machine learning as well. So, heterogeneous computing is especially important. Combining different processors and orchestrate them in the best way, achieving the lowest power consumption. We've seen this slide before. I'm showing this to talk about how our product lines are utilized in heterogeneous computing, how we can provide a best solution for heterogeneous computing. These are the segment focuses of imagination. The first one is automotive, second, mobile and consumer products, thirdly, data center and desktop, and lastly, computing. From the automotive in the left-hand side to the computing on the right-hand side are both about the automotive industry. So, imagination, in its various product lines, we can serve the automotive industry very well. Imagination is moving into RISC-V because RISC-V is a very open architecture and instruction set. It has more than 2,000 members. For innovation and R&D, it is a very powerful platform. And also for CPU, the most important thing is the ecosystem. In the past, for proprietary solutions, it is very difficult to build ecosystems because we rely on third-party software developers or hardware developers and system developers to develop an ecosystem. It takes time. But for RISC-V, it is developed really late as an architecture, but its ecosystem is developing very fast because it has so many members. So we believe its ecosystem will be built in a very rapid manner. Imagination technology was a member of RISC-V at a very early stage because we want to provide more solutions to RISC-V, not just only CPU, but also platforms solutions. Because in the platform, you need not only CPU, but GPU, and also hardware accelerators and network accelerators. And this is where imagination can contribute. But also, like indies and sci-fi, they're partners of imagination as well. For example, we are working with indies to develop a platform in which we include CPU and GPU. We want to provide interested customers a very simple platform and help them evaluate what type of application they need. And I look forward that in the near future we can RISC with more partners in more projects with all RISC-V members, including our EPP, for example, to build a more comprehensive platform. So customers will be able to evaluate what they need faster. As I said, imagination was very clear about the benefits of RISC-V Alliance. And I just list a few here, like the quality of our product. It is a very accepted standard product, a high standard product in the industry. And also we provide complementary IPs for RISC-V. So RISC-V can provide more direct and efficient platform solutions in this way. And let's move on the core of this presentation. That is our first RISC-V CPU, first developed by Imagination. And here are its features. Number one, it is balanced in terms of CPU design and efficiency and area. So it was able to create high performance in a limited area. Secondly, fourthly, it is designed to enable market-leading heterogeneous solutions. So again, this is something Imagination really values. If the customer requires a more advanced CPU, then one of our partners will be able to provide such products. Because our first CPUs is mostly for the mid-end product. And these are some detailed specs of our CPU. And it is an in-order deal issue 11-stage pipeline CPU. It's a 32-bit architecture, and we can support and we already includes relevant extensions, and not vectors not yet. And in terms of design, we try to increase performance, and so include some hardware design as well. And one of the features is that it is configurable, and so it provides options. So for caption, you can make choices, and its coupled memory size can be decided as well. You can choose to include some of the feature or not. So as a customer, if you are size sensitive or cost sensitive, you can choose to optimize for size. Or if you value performance more, you can configure our product. And the CPU's target segment includes package management, networking, and also storage controller. You can find that in these 6 different segments, many of them are in the automotive industry. We provide a very comprehensive software development kit. We call it Catapult SDK. For developers, we provide comprehensive design and also debugging functions. This is my last slide. We are now entering the RISC-V CPU market, and I hope that if you're interested, apart from RISC-V CPU, we also offer GPU, MMA, and MMP for all automotive applications. We offer many solutions. You're welcome to contact us. Thank you. Thank you, Principal Shi. I believe after this presentation, you must have more understanding of the RTX M2200. And the next speaker is the senior staff Shenchang Zhang from Microchip. So let us welcome senior staff Zhang. And the topic of his talk today is using PolarFire SoC FPGA to create power-efficient embedded solutions. Welcome.
Ladies and gentlemen, good morning. My name is Alan. So I'm very happy to have this opportunity to come here to talk about the SoC solutions. Actually, we had a engineer who was supposed to be here to make this presentation who unfortunately could not be here today. So today I will be talk about the So today we will talk about the SoC FPGA. So the biggest difference is that ASIC has a fixed circuit. However, the SoC FPGA, be it the processors or hardware, the SoC FPGA can be applied. So this is the outline of my presentation today. So I will talk about the PolarFire SoC. This is the industry's first RISC-V based SoC FPGA. I know that some other Intel, for example, Intel also has FPGA. However, they used ARM-based architecture. However, our PolarFire solution runs on SoC FPGA, and we will talk about the evaluation hardware, and then I'll move on to the demonstration. There will be the AMP demo, the asymmetric multi-processing demo, and then I will use Linux to run the OpenVX, and these two demos will be presented here today, and you can also find them in the booths in the back. And if you're interested in the products, you are welcome to come to our booth. We will walk you through how we operate them. The third demonstration will be H.264 compression with Linux. So like I said, our SoC is FPGA and SoC, so we have hardware and processor. So we also utilize the H.264 compression, and we will show you how we collaborate the software and hardware together. And then I will move on to bare metal image signal processing. So first of all, please allow me to introduce our SoC. Our SoC application addresses the edge challenges. We know that edge has become a trend in recent days, and they have been applied in IoT devices. And there are actually some challenges in the applications, and there are 4 of them. For example, thermal constraints, and then the minimal power budgets. The third is safety and security, especially if you are looking at the some of the monitors, you will need safety and security. And there's also another challenge, that is the real-time requirements. For example, the telemax or bots, all of these will require real-time capabilities. This is our previous products, the PolarFire FPGA. And this is the only flash-based FPGA. I think there are two benefits coming out of it. First is lower power, so we will be able to address the power problem. And then we have soft alloy. And because we are running on flash-based architecture, so we can address the soft error problem. And also we have PolarFire functions with the latest products. So basically, with our PolarFire, we will be able to address the challenges, three of the challenges that we list. Then, if you look at the Intel's SoC, they are ARM-based, but we are the only RISC-V based. So this is our signature SoC FPGA. We also support AMP mode, and you could use Linux and other operating systems. However, we can also use the AMP mode to carry out real-time applications. To carry out real-time applications, you will have to have the features of determinism. So how can we address all of that together? We will show you later in the demonstration session. Now, I would like to talk about the features of our FPGA. This is the PolarFire FPGA. So if you look at the different lines, you can see the competitors' products. The yellow dotted lines under the 1,500 core marks, our power is 1,200. But if you look at other, for example, Cortex A9 and Cortex A53, under the same core marks, their power runs on a higher power than us. So we are able to help save energy. Also, because we chose to run our product on RISC-V, so we can use the basic instruction set and scalable instruction sets. So the customers can choose to use the high performance features and other simple features. That is why we choose to use the RISC-V structure and architecture. That is why you can see that we are able to reduce some of the power. And now I would like to move on to thermal comparison. We know that the FPGA can be dynamically programmed. So if you look at these, the left is our PolarFire, and the other one on the right is our competitor. So the left is 2.7 milliwatt, and the competitors is 5.5 watts. So what's the difference here? And the impact, of course, is the thermal. So the average temperature is 52 degrees Celsius, and our competitors is 7.72 degrees Celsius. So there's actually a 20 degrees Celsius difference. That you can see the benefits coming out of this. On our IC, you do not need any fans, or you do not need any heat dissipation. So this will also help reduce cost because you do not need any ventilators or any fans. Now, if you take a look at this graph, you can see the PolarFire SoC RISC-V. If you look at the bottom gray area, this is our original FPGA, and the white one is our SoC, and then we also have added a processor on top of it. It is a coreless architecture, so it could be a 1+4 processor. On the left, it's monitor core, so it's used for monitoring, and on the right, it's application core. So there's actually 5 cores inside of it, and the highest capability is 627 gigahertz. And We also have the L2 memory system and DDR4 controller. Now, if you look at the SoC APG, you can use the processors to run operating systems. However, in our actual applications, sometimes you will need a PC, HPC, or image processing and other processing that will require large capacity. So you can use the FPGA in the bottom, and we have AMPA bar switch. With AMPA bar switch, we can switch information. This will allow us to decide whether or not our feature will be used in the hardware or in other parts. So if we do not need a very high computing speed, we can use the top layer. Now, I would like to talk about our evaluation hardware. Our PolarFire SoC has two evaluation hardware. The first is Icicle Kit. So if you see the silver part, this is the CPU, and it has been in mass production. And you also see microbus that is scalable, and we also have a PCIe connector. And PCIe can be used as our interface to send information. And we also have the other connector. The eMMC flash has 8 gigabytes, and it could be used for Linux image. So with that, we will be able to store them on the eMMC flash. If it is not enough, we also support SD card slot. So if you need more memory, you can use SD card slot. And this is our second evaluation hardware. It has to do with the video processing, so it's called Video Kit. Video Kit will have more interface that has to do with the image. For example, camera and HDMI. Now we have receiving and sending. So if you want to have some image and sound processing, you can use this. And there's also PCIe connector built in. Now, I would like to move on to our demonstrations. So, like I said, I'm going to show you AMP and SMP. So, the difference is that on the left is SMP. There's 4 cores. It's SMP. And on the right, it's AMP. The 4 cores can be used for 2 different operating systems. So on the first 3 and the last one can be used on different operating systems. So you can use FreeRTOS to process the real-time applications, for example, sensors. It's FreeRTOS. But if you want to use Linux, the other 3 core can be leveraged. So this is the demonstration I'm going to show you today. There are 2 panels here. One is real-time FreeRTOS, and the other one is Linux. So they will exchange information through their shared memory. So if you're interested, you can go to our booth and you will see this board there. The 2 panels will we will receive signals at different time frame, and they will send out the request through the Linux system, and then they will see whether or not they will be able to determine where the request is sent. Well, if you would like to find out, please come to our booth later. And the second demo is called OpenVX. So we use the processors. The FPGA is, like I said, it is the hardware, and bottom is the RISC-V hardware. So this is the second hardware that you can check out at our booth. So we are using the image processing on the processors. So the benefit coming from this is that the software will allow you to expedite your development. And of course, you would also see this in our booth if you come to our booth to check it out. So I'm going to skip this part, and we also have 2 other demos. However, we do not have this at our booth today. This is Edgepoint 264 with Linux, and with Linux they could be used to send out the compressed information. On the right you can see the bare metal ISP. It can be used for some simple image processing. So to sum up, we showcase the SoC FPGA. It's running on RISC-V with our FPGA transistors. So there's low power consumption, and it's flash based. Also, it's RISC-V structure. RISC-V architecture will help lower power consumption. And then the security is higher. And we also have AMP mode. So if you're interested, please come to our booth. We also provide real-time OS and Linux capabilities. So if you would like to find out more about the SoC, please come to our website and you will find more information there. Thank you. Thank you.
Thank you so much, Senior System Engineer Zhang. With these demos and the presentation, I believe you learned more about Microchip's products and portfolio. Again, there will be a lot of demos in their stand. You are very welcome to go and take a look. And so if you're interested, again, you're very welcome to go to the back of the conference room and know more. Let me invite our next speaker, Analyst and Research Manager Tom Law from DigitTimes. So let us welcome Mr. Tom Law. Welcome, Manager Tom Law. And the talk of his talk today is from DigitTimes Asia perspective of IC50, RISC-V development in an era of great power competition. Welcome. Thank you. I am an analyst from DigitTime. I'm Tom Law, and I'm very happy to be here to share with you our most recent research result on RISC-V. And DigitTime is offering marketing and media services in the industry, in the technology industry. Today, I would like to share with you a research called IC50 on semiconductors. We looked at all the entire Asian semiconductor business and look at each company, a different country, the role that they play in the market. And then we ranked the top 50 companies. And through this, we evaluate the entire business and market development of semiconductor companies in Asia. And how does this relate to RISC-V? I will talk about this later. Our service or our research is called IC50, or actually the role of Asia semiconductor industry IC50. It's already published in our official website, so you can use this link or simply search Asia supply chain IC50. You will be able to find the result of our research. But I believe you will still get the same information from me here today in my presentation. Let me share with you the structure of our research. In Asia, the semiconductor industry is important, but exactly how important? So after learning this, you will find the following results more meaningful. And so we'll begin with the content of our IG50 research, and at the end I will present you with the finding of the research and how this influence RISC-V. First, let's look at the Asia's position in the global semiconductor industry. I believe you actually know our position in Asia. I will so very quickly skip through some of the slides. I've listed here the top 10 semiconductor companies in terms of revenue and market cap. Most of the companies listed here are from the U.S., but there are three Asian companies like Samsung from South Korea, TSMC from Taiwan, and also from Japan, from Hynix as well from Korea. So 3 Asian companies. But if you look closer in the IC designers here, the ones listed in red are in Asia, like Realtek, Novatech, MediaTek, and Hynix are all from Taiwan. So in Asia, for the fabless ones, Taiwan's are really important as well. Then this is the OSAT, assembly and test services. Most of them basically are all from Asia, mostly from Taiwan and mainland China. This is for the semiconductor equipment companies. Again, 4 out of 10 comes from Asia, mostly from Japan. And this is the result of foundry companies, top 10. Again, out of 10, the top 10, 8 comes from Asia. So, in conclusion, Asia plays a very important position in the global semiconductor industry. We have companies at the top, but actually in the various industries under semiconductor, we play important roles in different ways. And so, what's the finding of our IC50 then? The most important finding here. First, I will begin with our research method. We look at all the companies in Asia with semiconductor relevant business, and we look at their revenue and their industry. And we rank them, and then we find 50, we ranked the top 50 ones in Taiwan and in other countries in Asia. Some of the companies did not have IPO, but they announced their revenue, so we include them as well. And for companies who include businesses in other areas other than semiconductor, we will take that part out. But some companies, however, they are not public traded, and they do not reveal their revenue. In that case, we do not include them. Like Xingyue Chemical, it's a very big wafer company, but they do not have a department dedicated for semiconductors, so we skip it as well. So this is our research method, and this is how we ranked the companies. So I will begin with the top 50 companies in our research. These are the top 10s in Asia. Simply put, I cannot list them all out for you, but in conclusion, in the top 10 companies, they're mostly from Taiwan, South Korea, and Japan. In terms of industry, 5 of them are in the IDM industry. They are from South Korea and Japan, and there are 2 foundries. But Taiwan has a more diverse business. TSMC for foundry, MediaTek is ranked number 5. It's for IC designer, and for ASE, it's OSAT. So in the top 10, and also UMC, so it's foundry. And so the top 10 companies coming from Taiwan spreads across different industry. This is the top 11 to top 30, number 11th to 30th. In the top 10, we see Taiwanese, Japanese, and South Korean business, but from 11th to the 30th place, you find more Chinese businesses. So from 11th to the 20th place, you see more Chinese companies like SMIC and JCET and so on. So 5 Chinese companies are found in the top 30. And then moving on to the 31 to the 31st to the 50th place, there are Singaporean business as well. So most important businesses in semiconductor are located in Taiwan, Japan, and South Korea. Some of them are also in Singapore, mostly in the equipment industry. And also the orange bars are from South Korea. I'm highlighting them to show you that South Korea, there are 3 companies listed in top 10, Hynix and also Samsung, but you find that you will only find other South Korean companies after the 31st place. So basically, it's a very concentrated market business for South Korea in the only in the top 2. So these are the ranking for the top 50. If you're interested, of course, you can go to our official website. So with this ranking, we did some statistical analysis to give you some results. In terms of companies, Taiwan takes up 17 companies, and followed by Japan by 14 companies, and then China 10 companies, South Korea 7 companies, Singapore 2 companies. In terms of industry, most of them are in the IDM business, 15 companies, plus foundry 7 companies. That means 21 in total. And then for IC design, for packaging and test, that there's 2 companies in OSAT, and so they spread across different industries. That was the number of companies. Here it is the revenue. On the slide, you can see that Taiwan also ranked very high in terms of revenue. Income in total, our semiconductor businesses generate very high revenue, ranked top, and followed by South Korea. But as I mentioned, South Korea, their revenue is similar to Taiwan, but they only have 7 companies, while in Taiwan we have 17 companies. So it's very concentrated for South Korea. But again, for South Korea, you see it's mostly the dark blue side, the IDM business, the IDM companies. And for other businesses in other industries, it's much smaller revenue. And then for Japan, and it's followed by Japan and China. This is the revenue in total compared with last year. But due to interest of time, I will just mention the conclusion for this slide. This slide is showing you for that across Taiwan, China, Japan, and South Korea, the growth rate is around 20%, but for Taiwan, it's smaller growth because at the beginning of pandemic, we were hit a little bit harder. So in 2021, the revenue was not so much a growth as other countries. But you can also see that Singapore has a very high growth. And also, revenue by the industry, you can find that for fabless, and that means IC, designer, and also equipment, they have 50% growth, and about around 50%. For IDM and foundry, one is 28%, the other is 21% growth. That was revenue. Now, moving on to operating income. Total operating income, also Taiwan ranked top, followed by Korea. And this is IDM. This is operating income by industry, but I would like to skip this one, and I would like to directly move on to the finding. From all the statistics we saw, we had some conclusion to make. First of all, you will find that, as I said, Asia is a very important powerhouse for semiconductor, but usually, especially in East Asia, out of 50 companies, 48 comes from Taiwan, Korea, Japan, and China. In terms of revenue, These four companies takes up 99% of revenue for the semiconductor business in Asia. So East Asia is really the powerhouse for semiconductors. And the second finding is that in Asia, Taiwan is of course playing one of the biggest role. We saw that revenue, Taiwan ranked top, 36.5% comes from Taiwan, the highest total. And in terms of operating income, it takes 40%. Taiwan takes up 40%, also the highest. Apart from that, other countries play important company as well. For example, TSMC and ASE in packaging, and also Fabless and DK. They, in the world, they also play important role. But do not forget, we have other top 5 companies as well. That was the first finding, and the third finding is that the semiconductor business in China is growing fast as well, getting robust. I've mentioned SMIC, JCET, these companies, and also Will Semiconductor. They're inside the top 20. So if you look at the future development of these companies, when compared to TSMC and UMC in Taiwan, SMIC, in terms of revenue, is really, well, it's not comparable yet, but for EMC and the SMIC, it's comparable. But if we look at CapEx on the right-hand side, and also the R&D investment, the SMIC is spending more than UMC. And for operating margin, it's more volatile, but its margin is also almost similar to TSMC sometimes. So that's China. And the other thing we can look at is the growth of the Chinese companies. This is another chart about operating margin. Apart from TSMC has more than 40%, and other companies, smaller Taiwanese companies, are also ranked top 3 in terms of operating margin. So the findings are leading to this final conclusion. That is RISC-V's potential in these IC50 research. First of all, the semiconductor businesses in China is getting robust, and we've heard a lot about the advantages of RISC-V. So just look at the bigger points here. Compared to other industries, RISC-V is rather neutral. That's important for Chinese businesses because, for example, ARM architecture was almost tagged with the U.S. sign on it, so it's more political. And whereas RISC-V is more neutral and not so much affected by the U.S.-China trade war. And also another advantage is that Taiwan is playing a very important role in the semiconductor industry. So in this industry, Taiwan is working closely with China. Taiwanese foundries like TSMC, USEM, Powerchip, their revenue last year, out of their revenue, 10 to 15% actually comes from the Chinese market. However, apart from this Chinese copper, apart from China being Taiwan's customer, recently we found that top 31 companies in Taiwan takes up more than 90% of the revenue for IC designer. In total, they have more than 50% of revenue coming from the Chinese market. So for Taiwanese businesses in the future, their customers is an important issue. If they have a stronger RISC-V profile, they can have a wider customer profile as well. So this is the conclusion for my presentation today. Thank you very much. Thank you so much, Mr. Luo from DigiTimes. Wow, really, time flies. We have heard some very exciting and impressive talks in the morning. We're able to learn more about RISC-V from all these different perspectives. Now, let us move on to the highly anticipated panel discussion. The panel will be conducted in English, so I will be speaking English from now on.
We will have the highly anticipated part of our events, the panel discussion. But before the panel discussion, we should have a group photo first. But before that, I would like to introduce our distinguished guest to come onto the stage. Now I'd like to introduce you the well-known master of Linux in Taiwan, Mr. Jim Huang, as our moderator. Jim is the assistant professor of information engineering at National Cheng Kung University, the co-founder of blockchain startup B Labs, and the developers and contributors to several world-class open source projects, including Android open source projects and LXDE. He also works as a consultant for MediaTek, ITRI, Delta, and Honghai Group, just to name a few. So let's welcome Mr. Jim Huang to come onto the stage. A round of applause. And next, let's welcome Tommy Lin from Sci-Fi, James Xu from Imaginations. Those speakers, you already know it, but again, let's use a round of applause and welcome them to come on to the stage again. And don't forget, we also have two more guests who will join us online. So let's welcome Gary Martz from Intel and Charlie from Andes. Can you see me? Hello? Is the connection, everything is okay? You may say hello to everyone. Hello, Gary and Charlie. Please say hi to everyone. And to make sure everybody's seeing you. Okay, it's over there already. So now we are going to take a group photos together. So we can look at the photographers in front of you. And Gary and Charlie online, also big smile, and we are going to have a group photos right now. So right now we're going to have our pulse V that represent RISC-V and also victory. So we're going to have our pulse V and also our guests from online have a V pulse. Okay, please take a seat. And right now I want to make sure that our guest online is also well connected and can hear our voice. If you can hear my voice, please raise your right hand. I don't think they can hear me, right? Sorry, we need some time to...
很小哎。
Can you hear me? Gary and Charlie, if you can hear my voice, please raise your right hand.
刚有一点声音，然后又断掉了。
Oh, okay. Sounds like some internet problems. So we might need some time to fix the problem. So please wait for a little while. Okay, so maybe let me introduce our moderators to share a little bit about our panel discussion and before we fix the problem.
Okay, so it's an honor for me to take part in this panel discussion. And before the discussion, I would like to quote from RISC-V website as follows. The potential RISC-V in automotive is real and is transition well beyond simply the early adopters. Two things are fundamentally changing: the concept of software-defined vehicle and the need for innovation at the design level. I would look forward to have a conversation with these distinguished guests and who have contributed significant to semiconductor industry. Charlie from Andis, Gary from Intel, James from Microchip, and Tommy from Sci-Fi. So let's go through the typical question: what are the greatest benefit and disadvantage in the design of automotive solution based on RISC-V? James.
Okay. Hello, everybody. Actually, I'm from Imagination. Okay. Okay. I think the biggest advantage for RISC-V is this is the open structure, open ISA, and it's geographical free, political free. So user don't have too much concern when they adopt RISC-V architecture into their design. Okay. So for the automotive, this is a very, I think when go into the smart car age, this is a very challenging task because so many complicated application will be applied into a single car. Okay, so with the spatial extension, which can be developed from the society, RISC-V society, it is very good. People can target to develop a very...
Just would like to emphasize on the importance of customized instruction. Okay. So Tommy, how about your idea?
I think the most important thing is RISC-V is an open standard and the flexible and modularized nature of its design. And then it's easy to migrate and integrate to provide just fitting solutions to the trend of our software-defined vehicles and more feature applications. And I think in the business perspective, it's also provide multiple choice and the freedom to choose which the CPU, the tools, the software you applied in your design.
So the importance is integration between software and hardware and as a multiple choice. Okay, so Gary, can you answer? Gary?
Advantage for RISC-V is that we're able to start fresh without a lot of legacy technical debt. This is going to allow us to be efficient and highly optimized designs for very specific applications. This advantage is also the biggest challenge. You know, we've already done a lot of work across the RISC-V ecosystem. A lot of products are already shipping, but as an industry, we still have a tremendous amount of work to complete. The majority of the existing cores are targeted for the embedded controller use cases. Cores for the medium and high performance usages, especially in automotive, zonal architectures, IVI, ADAS, still needs to grow. And then clearly functional safety, design and certification is a requirement that we must address for the automotive industry.
So it's about the high-performance computing for a new market, such as automotive, right?
Yeah, definitely.
Okay, cool. So Charlie, can you answer this?
Yeah. So I think without going into the detail, the RISC-V advantage, we still need to go to open, extensible, compact. Yeah, automotive is not much new in terms of technical side, other than you need to go through the functional safety to certify to make sure it's kind of robust. You want to drive a car which with all the chip gets certified instead of just ready. Open is very important. Berkeley is a great school, but if they didn't open it and didn't bring it to the to form the RISC-V Foundation International, it probably would be just another open RISC. So the difference is quite big. With open, so we have a lot of collaboration, and now RISC-V International formed a couple of SIG related to automotive, like automotive SIG and RISC-SIG and things like that. In terms of feature extensible, also something that I want to talk about because it's automotive. When you go to a lot of area, it's kind of has a lot of specific optimization, different vendor, that they're kind of innovation. Even though RISC-V is great, architecture continue to evolve, you're not going to cover, using the standard set, you're not going to cover all the requirements which vendor to follow. So with extensibility, then they can, we can unlock all the potential that RISC-V has. And this year, we provide an automation tool to help customer to kind of achieve that without kind of tearing down the RTL that we provide to them. So I think RISC-V has a great potential in the automotive.
Okay, so the impact is around the innovation from RTL level, hardware and software integration, and even for functional safety challenges. So the next question, we are all aware of Taiwanese importance and the dominant position in semiconductor market. And what do you think the needs for Taiwanese semiconductor company to improve or increase their technical capability in RISC-V? And how should they then invest in R&D resources? Charlie, can you answer this?
Right, so last one first. Okay. Yeah, so I think RISC-V is a great architecture, and now it become a great computing platform, and which define a lot of things which can build on top of that. All kind of SoC, not just automotive, embedded, and communication, data center, and things like that. So it would be kind of very pervasive and define computing platform environment. And so I think Taiwan's IC company in the past usually just kind of adapt the standard, but I really want to encourage them to kind of invest more resource to look into the RISC-V and see how they can leverage that, and also kind of join the RISC-V International, join all the task group, the technical discussion, so that they can influence the technical direction for their best use. That I think that's one thing, and definitely one step before that is that a lot of time when we talk to customer and the top level management want their engineer to do evaluation, but their engineer are too busy, and so they don't have time to do evaluation. So I think this is really a fast growing time, and RISC-V has a lot of success. So I really encourage the management to give their engineer time to really take a hard look at the RISC-V and to see how RISC-V help your competitors.
Okay, thanks, Charlie. So Charlie encouraged Taiwanese company to get involved in RISC-V standardization along with the ecosystem. So how about your opinion, Gary?
Yeah, thank you. I mean, Intel has a long history of contributing to industry standards, and our efforts always include three basic elements. we need to build a trusted foundation for innovation within the organizations that we participate. And RISC-V has definitely built that. Then we use standards to allow the ecosystem to choose the best solution for each generation of technology. And we leverage the open source software ecosystem to drive new solutions to market quickly and expand the economic opportunities for everyone. The RISC-V ecosystem and the Taiwanese contributions have to move forward together globally to respond to the big issues in the industry. Some of these include performance, security, preventing fragmentation, and also supply chain stability. We're going to need to continue to develop the specifications and software around the essential applications such as automotive, AI, data center, as a few examples. In addition, we need to look at RISC-V fitting into existing ecosystems. Investing in a common interconnect standard such as UCIe is also a must, and probably the fastest way to grow the RISC-V market by building RISC-V solutions that can be combined with the chiplets and IPs from the existing x86 and ARM ecosystems. I think these are the areas that Taiwanese semiconductor companies can also focus to increase the success of RISC-V.
Okay. Thanks, Gary. So Gary wants to emphasize on the new chance that we can collaborate from the definition of new instruction set, new extension, and the approach based on open source technology to enable the domain-specific applications. So, Tommy, what's your opinion?
Okay. I think we need more trials, more multidiscipline and collaborations to Taiwanese companies, especially there is a trend because in the past, Taiwanese company always the followers or the fast movers. But I think since RISC-V is an open standard and it's an open field for all players, so it's a chance for Taiwanese company to be the pioneer to do many different things in this game.
Okay, that's what I think that's very important to paradigm shift. We at the past Taiwanese are a follower, but right now we are maybe moving forward as a standard participant and enable faster movement. That's good. So, James, how's your opinions?
I think the biggest challenge for Taiwan's semiconductor RISC-V camp on the automotive industry, I think right now the concern is the acceptance of the automotive supply chain. From on top of IP vendor, there's a SoC supplier, then to the tier 1 supplier, then to the OEM or car manufacturer. Automotive is a very conservative industry, so to be accepted to this market need much effort to do it. I think the functional safety is one of the critical items. I think so far, I think the Taiwan industry has overcome that on the RISC-V CPU. However, the ecosystem and also the application model, which can be accepted by SoC vendor, that's the first step. Then go to on top of the supply chain to be accepted gradually. I think so far, the RISC-V CPU are already been adopted on some of the sub-module of the automotive. But for the key module, I think we still need a big effort to invest more resources to develop high-end application CPU that can enter to the main module of the smart car. I think not need a lot of investment.
Okay, since Jay, since Jay, so that is it opens a new door for the supply chain, right? So Taiwanese company can overcome the existing problem that Taiwanese company usually could design the major component instead of the critical component, right? So I just want to follow. So how can this Taiwanese company can invest more to speed up the transition and adoption? So such as more survey environment, hardware participant in RISC-V standards.
I think the CPU developer can not only focus on CPU level itself to do development, need to cooperate with the system level. For example, co-working with the SoC vendor, co-working with system vendor to have a global view on the platform. So if that, then when the CPU come up with a good solution, that will be if good for the purpose and for target some specific application, then hopefully can propose the good value proposition to the supply chain. Yeah.
Okay, so from the perspective view of the supply chain, it must be highly integrated, not only the scope of each unit. So I think that's the power of RISC-V. And so, okay, once more, many thanks for this honorable guest. And the conversation with them taught me a lot. And then it's a Q&A time. Please raise your hand if you have questions and would like to talk to this guest. Do you have any question? Okay, so someone might wonder what is the starting point for company, especially in Taiwan, to get them participate in RISC-V community and the ecosystem. So Charlie, could you say something for this company who would like to enter in RISC-V?
Okay, so there are several different ways. So the formal one is first join RISC-V International as a member, and and then you can join. You can subscribe to different discussion forum or the task group or SIG. Actually, you don't need to be a member to involve that, but you need to be a member to vote when there's a decision like a spec and things like that. And there are many different technical area to discuss. So definitely, I think it's right now it can grow into, I don't know, 40 something, 50 something, or maybe even more. I'm always kind of lost track of that. But you can go there to check it out, the list, and to see what is most important to you. Also from there, we can find a lot of open source activity there. And last, if you are not able to find anything that you're interested, you probably place to enter, please come talk to us. I think Andis has a lot of experience with that. We can kind of chat with you to help you find the direction that you want to get involved. So come join RISC-V.
Thanks for the sharing for Charlie. So Andis itself is a good example to get it involved in this RISC-V ecosystem. I think Taiwanese company can follow the role model as Andis does. So do you have a question? Okay. So Gary, what's your opinion for companies to participate in RISC-V ecosystem?
I think Charlie covered most of it. I mean, first and foremost, get involved. Join RISC-V International, participate in the discussions, the conversations. One thing that I heard, and I like to repeat it, is, you know, standards can take a long time. Standards can be a bit messy. But when we're done and we have the final product, no one ever looks back and says, well, I think we talked too much. I think we took too much time. Generally, we've proven time and time again that the level of conversation, the debates, the passion lead to the best results. For that to take place, we need to have a broad base of participation globally. And so, like I said, I agree with Charlie, get involved. And then allow your engineers to pick up projects. Start looking at RISC-V as a potential solution to your own customers' problems, and allow the engineers to do what they do best and to develop those solutions using RISC-V.
Okay, now thanks, Gary. So the most important thing is conversation, right? So conversation at the beginning, conversation in the participating in this project, especially many of them are open source right now. So companies, especially in Taiwan, can follow the activity and send some feedback. So we have one question, right? Please.
Hi. Sorry, so for my question is more like for open source, basically open source anything often comes with a security issue or security risks. And then for RISC-V, with it being an open source architecture, would the same issue, like how do you address that issue, especially when it comes to like more cars becoming more connected in the future, especially when people are aiming for autonomous cars, they will basically have to be connected all the time. So will security be an issue? And then if it is an issue, how do you address it? Thank you.
Okay, so very good question. So security is a very important concern in automotive ecosystem. So Tommy, what's your idea?
Okay, since the RISC-V is opened in instruction set architecture level, but we can choose or we can implement many details to secure everything from microarchitecture to hardware level to the operating system and the software. So in each level or in the hierarchy, we can do many things to secure what we want to protect.
Can you say some more practical example?
For example,
I mean the new extension of some early models.
Extension, because you know the security is the whole thing, so you must combine everything from the origin of hardware design to software to applications. So in the CPU side, we provide some function capabilities and also connect with the tools, BIOS, booting. So we can secure each part to be monitored or secured well, and then to ensure everything works fine.
Okay, so that's a very good important inspiration. So it's security itself is not a product; it's a process. So you have to ensure everything is secure and not only quite usable but deterministic. So from skill boots, system integration, OTA, and so on, especially for the functional safety.
Yes, it's not a single thing, but a total big thing.
Okay, so just.
I think in addition to the secure boot, I think there's also a mechanism called hardware virtualization. So hardware virtualization can partition each hardware platform, CPU platform, into several OS domain. You can have some application OS domain or secure OS domain. And on the secure OS domain, you can have a lot of protection to protect the hacker to come into this hardware region in addition to the memory location, or also inside computation. I think also the cryptography also can have some encryption to secure the data safety.
So with the help of hardware-assisted virtualization, we can isolate each component. So we can ensure the whole functionality work as expected and as skilled, since we can efficiently operate many software components without the security risk, right? So how about can you how about the model example? Have you heard or can you share about the product side? So, some example or some
product side, for example, in the automotive, okay, you can run the Linux as the open application OS to run on the dashboard, run on the entertainment system. So in case that OS is hacker by the intruder, that's okay, because not safety related, okay? But for some breaking system, other things is run on the secured operating, real-time operating system, they cannot be intruded. So that's the case I can think of. Yeah.
Okay. Thanks, James, again. So I think the conversation is quite inspiring, and thanks again, James. Oh, sorry.
May I have a comment?
Oh, good. Please go ahead.
Okay, I think the question was whether open source makes security not secure.
Yes.
Not what kind of security feature it is. So I think there are two levels of things, right? One is security by secrecy or security by openness, right? So I think open source at this level, for RISC-V level, is the spec, right? So the difference between RISC-V's spec and ARM spec is that, I mean, everyone can read ARM spec, but you cannot implement it. So ARM spec is also there. And RISC-V spec is open, and if you are able to implement the processor by yourself with your team, you can do it without paying any royalty for that. So the spec itself is there, and advantage of RISC-V being an organization and open forum discussion and voting the spec is that everyone can come here to help to point out whether there's an issue here, how to enhance it, and things like that. And if you do join the RISC-V discussion forum, you find a lot of veteran engineers. They've probably been working on this field for 40 years, 50 years, and now they are retired, but they have a lot of time to come here to help to review it. So at this security for openness, we have this great community to help us review the spec. And after the spec, like Tommy said, the implementation part, microarchitecture, those are the kind of detail. Maybe some company would introduce some bug there, like floating point bug for famous company a while back, and also other what's that? Spectrum meltdown. I think that affect quite a lot of leading chip. Those are kind of microarchitecture implementation, but I think we learned through that experience. So every company had to kind of to implement processes, they had to kind of cover that part themselves. But that had nothing to do with the RISC-V spec being open.
Okay. Thank you again, Charlie. So Charlie, emphasize the importance of innovation in RISC-V. So some side channel attacks such as meltdown and spectre are very difficult to defend. But with the community and ecosystem in RISC-V, we could look for more opportunity and new technology around them. So thanks again, Charlie. And I would like to thank Tommy for joining this panel discussion. Of course, Gary, thanks for coming. So I think it's time to end this conversation. Okay, thank you. Bye.
Thank you.
Thank you. Thank you.
Thank you for our distinguished guests to participate in our panel discussion. Also, our guests online. Thank you so much. Gary and Charlie, thank you so much. Let's give them a round of applause again, okay? Thank you to come participate and also our guest on the stage. So 非常感谢各位贵宾今天的莅临。2022 RISC-V Taipei Day 论坛呢就在此进入尾声。They are saying goodbye to us. Goodbye. 好，非常的热情哦。那也感谢今天所有贵宾的莅临参与。相信呢，不管是在panel discussion 或是在我们的 keynote speech， 大家呢都了解了更多关于 RISC-V 更多不一样的应用，以及更深入的了解。那刚才还有 Q&A 时间，相信呢这样子的互动呢是大家非常期待，而且未来呢相信未来也会有更多的切磋，以及有更多精彩的火花。那我们的论坛呢就到这边告一个段落。那我们目前的荧幕上方呢，有展示出我们的 QR code。如果你想要关注更多相关议题的发展的话呢，欢迎扫描我们荧幕上的 QR code， 可以免费的加入我们台湾 RISC-V 的联盟，随时关注我们的官网，更新相关的资讯。那当然也感谢我们台上所有的嘉宾朋友们来为我们进行这个 panel discussion。那如果你有兴趣的话呢，欢迎扫描我们上方的 QR code， 可以获得最新的资讯。那加上呢，关注我们的官网，我们会把最新的消息都为各位进行一个更新，也免费的加入台湾 RISC-V 的联盟，让我们一起让RISC-V 这个科技呢，未来蒸蒸日上，相信有大家的共同努力呢，我们一定会越来越顺利。欢迎随时关注我们的官网，更新相关资讯，期待大家下次再见。感谢大家，我是今天的主持人台湾小姐邱怡树。
Thank you.
那主持人这边呢，也小小的提醒各位，待会呢，各位嘉宾在离场的时候呢，也帮我再次的出示你们的证件，让我们的工作人员扫描，再进行离场。所以，请嘉宾们要记得在离场之前，要先将您的证件让工作人员扫描，再离场。非常感谢各位贵宾的配合。
Thank you.